Algebra, we are continuing our talk on PO6, which is writing and solving equations in real context. Just a reminder, the method that we're going to be talking about is called opposite operations. We are undoing the equation, undoing what is being done so that we get n by itself. We talked about an equation being like a scale, a balanced scale. That's why what you do to one side, you've got to do the other, keep that scale balanced. And we've done all four of these. You should have those answers in your binder. Okay, we'll review some more on the second page, but those should all be done. So, looking at what we have here, word problems are, we talked about this in CO4, are inherently difficult because you've got to take out what information you are being given and set up the equation yourself. You've got to figure out not only what's going on, but then how to answer the question, how to solve it. Okay. So most equations that you're going to be working with will have a variable, a coefficient, and a constant. We've talked about variable before. What is a variable? What is a variable? Yeah.
It's a letter.
Usually a letter that represents what? A value. Okay, an unknown value. And I'll add in here an unknown or tested, because as you'll see in the equations we're working with down here, the variable is going to represent, a value that we're going to test different things for. Okay, say what happens if this or this or this. So it's an unknown or a tested value. Just like in a science experiment, right? A variable is something that you can potentially change. It's something that you're testing. Okay, a coefficient. What's a coefficient? Where is it in the equation? What's its role? You go.
Like the thing that multiplies it.
Okay, so it's the number before a variable and it's how many variables you have. I should say how many of the variable, not how many variables. How many of the variable you have. Okay, like we saw in the equations above, if we were to get down to something like 15 n equals 60, and we were solving for n, this tells us n's the variable, 15 is the coefficient. This tells us 15 n's make 60, but we don't want to know that 15 n's make 60. We want to know what the value of 1 n is. That's why we divide by 15 to cancel it out, and we get 1 n equals 4, right? But that coefficient is the number that comes before the variable. It's how many, in this case n's, but how many of the variable we have. And then a constant. A constant, yeah.
You think you could add or subtract?
Yeah, it's a number without a variable. It's kind of like an initial value. It's where you start. Okay? It's something that doesn't change. It isn't affected. It's a constant, right? Constant means doesn't change. Okay? It's your initial value, and we'll add in here not affected by the variable. It stands alone. Just like me at dances in high school. Stands alone. Okay, so here we go. You sign up to help a charity with preserving the rainforest. That's noble of you. They ask you for $20 up front, and then you'll give $2 per month after that. Okay, so you give $20 right away, and then however long you're a part of this charity, it's $2 per month. What's the equation that represents the situation, and how much money will you have given after 6 months, 8 months, and finally 2 years? So we're looking for what's our variable, what's the unknown or the tested value, what's our coefficient, the number before the variable, how many of the variable there is, and then what's the initial value, what's the constant, what isn't affected by the variable. We'll start with the variable. What is the variable? Yeah?
The amount of money you get.
Not the amount of money, that's kind of the total. That's what we're trying to solve for with this equation. Chance?
Like the month?
The months, I'll come back to you, okay? The variable is the months, right? And you can kind of tell that because that's what I keep asking you. That's what we're testing, right? How much after this much or this long? How about this long? How about this long, right? That's what's being tested. So and we'll use M for month just because it's, makes sense, okay? Now with the coefficient, theta, 2, right? It's how much is being given per month, okay? It's that number before the variable. However many months that we're in this, it's $2 per. Remember that word per means to multiply, okay? So 2M, $2 per month. What's the constant? Gus? 20. Why? Because it's initial. It's where you start. If you're part of this charity for a month or 20 years, you're still giving $20 that first time. Okay? So this expression is going to represent how much money you give over however many months to the charity. Okay? $2 per month plus that initial 20. Make sense to everybody?
Yeah.
Right? So now we get to the testing phase here, right? And this is where last year I had to make an XY table. Here it'll be a month and money table, I suppose. After 6 months, how much have you given?
$32.
And how'd you get that?
You do the 2 times 6,
Yeah.
which is 12 plus 20.
2 times 6 plus 20. 12 plus 20, you've given a total of 32. How about 8 months? What'd you get? 36? And how'd you get that?
2 times 8.
All right. 2 times 8, 16 plus 20, $36. How about 2 years? What's being plugged in for M here? Chance?
I got 68.
And how'd you get that?
Well, I did the 2 years, I converted it to months. Which
Yes.
is 34.
Right.
And
You-
times it by 2, and then added 20.
Yeah, that 2 years, when there's a unit change, you've got to convert that to your units the variables in, right? 2 years is equal to 24 months. So 24 is what we'd have to plug into our equation here. 2 times 24 plus 20, that's going to give us 68. Okay? So whenever you are dealing with different units, make sure you convert to the units of the variable. Since our variable is in months, we've got to convert that 2 years to months. Questions? Okay? All right. Next one. Mr. Schultz has 3,039,001 hairs on his head, and each day he loses 60 of them. Write the equation. How many hairs will he have left after 120 days, 1,580 days, 50,650 days? Let's run through our list of items here. What's our variable? D, right? Days. That's what's being tested. That's what's being asked. Okay? Coefficient and constant. What do we think here? Gus, give me one.
I think the coefficient is 60.
60. Why would it be 60?
Because I just tell you what I'm thinking.
Sure.
So you lose 60 of them each day, right? So you have to do multiplication of how many days. So you lose each day you lose 60 from 3,039,001.
Yeah.
So,
Now, you're saying that you lose 60 each day. Now, think back to CO4 and all those words, phrases, things like that. That word lose, what operation is that kind of? What? Subtraction. So it's not just going to be 60. Mario?
So 3,039,001 years, that number changes after every time you test it, but 60 doesn't change. So I think.
Well, the 3,039,001, that's your initial.
Yeah.
Right? The number of hairs on my head changes, but that initial value is always what it's going to be, right? Kind of like in the last one, yes, the amount of money that you give changes over time, but that initial 20, what you started with, that was always 20. I'm always going to start with that, okay? Split. Let's get back to that 60, Gus.
So, yeah, I think it's 60 because after 2 days we would lose 120.
Okay, but if that word lose, you said means subtraction, how is that going to affect the 60? Evelyn? Negative 60, right? Because I'm losing that number of hairs each day. That 60's got to be negative, right? Because the amount is going to be decreasing. That 3,039,001 is decreasing. So at this point, you can either write that 3,039,001 first, because that's what I start with, and then I lose 60 hairs each day, or you could take negative 60D plus 3,039,001. Either way is fine. You'll get the same answer. Okay. In both cases, this 3,039,000 looks like negative God. I should probably not let Mr. Boy. That didn't help. Anyway, okay. Yes, that is what I'm. 60. Anyway,
Still God.
either way is fine because in both cases that 3 million, that starting value is positive, and the 60D is negative. It'll work out the same. Okay. So first we want to figure out after 120 days. So this will be a D and H chart. The number of days that's what's being tested, and the number of hairs. So after 120 days, how many hairs remain on my head? You are allowed a calculator. Yes. Oh, show. Jonas, yes. Well, we're not there yet, Jonas. Let's not jump too far ahead here. We want to get the viewers and the subs their money's worth and get through the whole objective here. Who has it? 3031801. There's that. Throw some commas in there. 3,031,801. That's still a lot. Got a nice flow there. After 1,580 days, what we got? Jonas. 2944 what? 141. A couple of commas in there. 2,944,141. And finally, after 50,650 days, how many hairs do I have left on my head, Jonas?
1 hair.
Just 1 hair. My plan is to have that 1 hair be super, super long, so I can just kind of like wrap it around a bunch of times and make it look like there's more. So it's my plan.
You're actually losing 60 hairs.
I am.
Probably more than that, actually. Yeah.
After 20,000 days, you're going to be very old. At least 130 years old.
Oh. Well, then I guess at 138, if I have 1 hair left, I should be pretty proud of myself. Yeah. I've never actually had someone calculate how old I will be after 50,000 days. Thank you, Jonas. That kind of puts this question in perspective. Okay. Questions on it? Comments, concerns, complaints, comments, congratulations, criticisms. Yes. What is your concern? Oh.
Congratulations on 1 hair.
Thank you very much. Appreciate it. All right, your assignment for tomorrow. The second page of PO6, and there is only 1 more page of PO6. You've got 8 two-step equations to solve. I highly recommend opposite operations. You do need to show all of your work. So if you do guess and check, if that's really what you want to do, then you've got to show me the work that you did to guess and check. What did you guess? What did you check? How long did it take you to find it? I need to see. If you insist on saying, no, Mr. Schultz, I'm going to do it my way, then I need to see all the work for your way. And if you come in tomorrow and you say, yeah, Schultz is the greatest thing. The first thing I plugged in on every single one was the answer. What are you going to do? No. No. Okay? No. Then word problems down at the bottom. Says you are just starting to collect baseball cards and already have 30 that you got from your parents. You go to a trading store with 3 of your friends with the agreement that however many cards the group gets, you'll divide them evenly among the 4 of you. There's a key word. Divide them evenly among the 4 of you. How many cards will be in your collection if the group gets 40 cards, 96 cards, 224 cards? Okay? As a scuba diver descends into deeper water, the pressure of the water on the diver's body steadily increases. The pressure of the surface of the water is 2,117 pounds per square foot. The pressure increases at a rate of 64 pounds per square foot for each foot the diver descends. What will the pressure of the water be when the diver heads out 10 feet, 25 feet, 150 feet? Okay? So, a couple to play with there. Any of these you want to go over? Review that operations method?
The word problems.
No.
How about we just
Any got one for me?
That's the point.
Oh. Anybody?
All of them.
Hit 'em.
Would the first word problem be division?
You can write it as division or multiplication, because if you are dividing by a number, that's the same thing as multiplying by the reciprocal of that number. For example, if you are dividing 50 by 10, that's the same as taking 1/10 of 50. So you could write it as 50 divided by 10 or 1/10 times 50. It'd be the same result. So you can use both. You can use either. Any of these? 8? 8.
What's our reciprocal?
Reciprocal is the number upside down. So like you flip the fraction. The reciprocal of 3/4 would be 4/3. You flip it. If you've got an integer like 10, technically as a fraction, that's 10 over 1. So the reciprocal would be 1/10. None? You just want to just go for it?
Yes.
All right, okay. Homework to tomorrow, PO6. That's how you math.